Okay, now let's talk about the pressure difference across a curved surface. Alright, so now you consider a bubble, okay, an air bubble in the water. Okay, and then now you have a bubble in the air. Okay, so this is air and then this is water. Okay, so that this is air, this is the thin water film, and then outside the bubble you still have some air. Okay, so let's take a look at the air bubble in the water first. Okay, so yeah, the outside pressure, which is the water pressure, will act on the bubble surface in all directions. And then now when you try to cut open the bubble, okay, you cut it open, so you know that the surface tension will actually try to keep the bubble intact. Okay, I mean the surface tension is the cohesive forces between the water molecules. So you know that the water molecules on the surface will attract one another, and then these hydrogen bondings of the water's surface are exactly the cohesive forces which are responsible for your surface tension. Okay, so you know that the surface tension force is actually acting to this direction, okay, because they try to attract the surface water molecules among one and another. And then you have some air inside the bubble, so you still have some pressure inside the bubble. Okay, and then when you have cut open the bubble, you know that the pressure outside, actually they are acting in all directions. Okay, and then the pressure inside is actually acting in all directions as well. Okay, that means that I should have drawn the pressure inside the bubble in this way, in this way, in this way, in this way, in this way also. Okay, so you know that you have to take your effective area. Effective area is the area where you can see the bubble. For example, let's say this is a 3D bubble. Now the effective area you are able to see the bubble is actually pi r squared only, because it now becomes a 2D diagram. Okay, so the effective area is pi r squared, not 4 pi r squared for a sphere. Alright, it's only pi r squared for a sphere, because this is exactly the area where you can see when you take a 2B picture. Okay, so you know that the pressure inside times the effective surface area is exactly the force to the left direction, and then pressure outside times the effective area is the force acting by the outside pressure in this direction, okay, to the right. And then gamma times 2 pi r is the surface tension force, which is acting to the right also. Okay, so you have to know that we use effective area so that we don't have to resolve. Okay, we don't have to say, oh, I resolve the force here to this direction, I also resolve the force here to horizontal direction, I also resolve the force here to horizontal direction. No need, you just straight away use the effective area, and then I can know that the force is in the horizontal direction only. Okay, so the key part here is that you use 2 pi r, because this is the effective length where the surface tension acts. And then for this one, right, now you have one interface and then another interface, so you have two interfaces altogether. So therefore the effective length is this inner circumference and also the outer circumference, so you know that the effective area here is double. Okay, and then of course you just think that the thickness of the film is negligible, so that this 2 pi r of the inner circumference is exactly as the 2 pi r in the outer circumference. Okay, you just assume that the thickness is so thin. Okay, so you have to know that the pressure inside the air bubble is slightly higher than the pressure outside the air bubble. Okay, and then this is the Laplace law for a spherical membrane. Okay, because you only have one interface. Okay, so that, and then this is the Laplace law for two spherical membranes, because you have two interfaces. Okay, so now when you connect two balloons, or maybe you connect two soap bubbles of different radii, and then you have a valve here, okay? So what will happen if you open the valve? Okay, let's take a look at this. The radius of this balloon is smaller than the radius of this balloon, okay? R1 is smaller than R2, so that you know this term is greater than this term. So you know that the pressure inside this bubble is much larger than the pressure in this bubble, okay? So when you open the valve, since the pressure here is higher, right? So they will push the air from here, go to here, go to here. Okay, so you know that the small balloon will get smaller and smaller and smaller, and then the large one will get larger and larger. Okay, just like the poor people will get poorer and poorer, and then the rich ones will get richer and richer. Okay, so yeah, in the next video we will talk about capillary action. Thank you.